Welcome to video 2 for our rays, angles, and links section. In this video, we're going to talk about angles. Okay, so angle XYZ is formed by two rays that share an endpoint called the vertex. We've got to name our angles with the vertex in the middle, and the other 2 points are on each of the two rays. Let's look at an example. Example XYZ. This is angle XYZ right here. And it's, oops, that was rough. It's right there. That's angle XYZ. Really make sure we know what we're talking about here, right? That's the angle. So we could write that in two ways. We could write it like this, angle XYZ. And note, we could also, the angle symbol is that, it's not a less than sign. It could also be this angle symbol. What's another way I could name that angle? As long as the vertex is in the middle, I can switch the endpoint. So I could call that angle ZYX. Either is fine. Those are both referring to the same angle. Okay, so sometimes you'll see angles that are numbered. For instance, angle 1. Right, angle 1, you could write it like this, angle 1. Or, in this case, remember vertex in the middle, we could call it YZ. Angle G. Whoops, angle G went a little crazy on us. Let's go ahead and up. Enough. Angle G. Over here. Okay, again, we'll take it. There's angle G, so we could call it angle YZG. Or GZY, right? Either of those are fine. Angle G, we can only name an angle with just one letter if it's the only angle that could be assigned to that letter. So for example, angle G is an angle. We know that it refers to what angle? It refers to angle YGZ. And you could be smart and you could say, oh, well, it also refers to angle CGY. But those are the same angle, right? It would be bad to choose angle Z, right? If we just said angle Z, then that could be this angle YZG, or it could be angle YZX. We don't know. So only use a letter, just one letter, if you know what angle it is, if it could only be that angle. Okay, sometimes we're going to talk about the measure of angles, how many degrees an angle is. So for example, the measure of angle R is 40 degrees. We would write that as the measure of angle R is equal to 40 degrees. Not too shabby. Okay, let's talk about congruent angles. Congruent angles. Well, what does congruent mean? Right, what does congruent mean? Congruent is the same size and the same shape. It's kind of like equals for geometry. So for example, if I say angle 1 is congruent to angle 2, I would use a mark like this to say angle 1 is congruent to angle 2. So that is how we show congruency. You could also, if you had more than two angles that were congruent, right? Like if you had two separate angles, maybe we can draw it like this. If I had an angle here and an angle here, and those were congruent, we could use two lines like that to show congruence, right? That's what I like to use. Or 3 lines or 4 lines, whatever. This shows that these two angles are equal to each other, but they're not equal to these two angles. Okay, so congruent, same size, same shape. We write that like this. We write it as, we would write angle 1 is congruent to angle 2. And that's different than saying that the measures are the same. Okay, I know that that's kind of tricky, but saying angle 1 is congruent to angle 2 is not the exact same thing as saying the measure of angle 1 equals the measure of angle 2, even though both of these things are true. If I say angle 1 is congruent to angle 2, I'm saying it's the same size and shape. If I say the measure of angle 1 equals the measure of angle 2, I'm saying they have the same angle measure. So again, it's different ways of describing the same thing. Okay, so equal signs are used for, usually we see them in algebra, right? And they're used for numbers. Versus congruent symbols. Congruent symbols are used for geometric objects. So equal signs are used for algebra and numbers. Congruent symbols are used for geometric objects. Two other signs that you'll see later in this course, that's similar, it's just one squiggly line, versus congruence, which is the equal sign with a squiggly on top, or approximate, which is two squiggly lines. Okay, so that's congruent angles. What about adjacent angles? Okay, adjacent angles, these are angles, maybe we can get some more space. These are angles that share a vertex. And they have a common ray. They don't share any, what's the best way to say this? They don't have any space on the inside. They don't share any interior points. They don't overlap. Okay, so let's give some examples of what this might look like. So adjacent angles, we've got here and here and here. Okay, I'm gonna go ahead and cheat a little bit, make this a point. Call this point A, call this point B, point C, and point D. And I'll go ahead and name these angles. I'll call this angle 1. Oops, and this angle 2. So angle 1 and angle 2 would be adjacent angles. I wouldn't call something like angle BAC, right, angle 1. That's not adjacent to angle BAD. Right, they're only adjacent if they don't overlap. So hopefully pretty straightforward. Adjacent angles right next to each other, they share a vertex, they have a common ray. Okay, so we're gonna skip over some stuff and get to talking about different, different types of angles. Okay, we just talked about adjacent angles. There's a special type of adjacent angles that we should pay attention to, which is angle bisectors, right? Bisectors of angles. Okay, so bisectors of angles are an array that divides an angle into two congruent angles. So again, let's do here and here. That's an angle. And if we have an array that divides it into two congruent angles, I'll draw that in green. That's about right. Then we call that a bisector of an angle, or maybe even more importantly, I would call that an angle. This right here, maybe we use that right there is an angle bisector. Just an array that divides an angle into two congruent angles. Okay, an acute angle. Acute angle, it's nice and cute, it's small. It's an angle that measures between 0 degrees and 90 degrees. A right angle is an angle that measures exactly 90 degrees. Put our little degree symbols here. An obtuse angle measures between 90 degrees and 180 degrees. And a straight angle measures exactly 180 degrees. Now, in geometry, when we talk about angles, we are talking about angles that are greater than 0 degrees and less than or equal to 180 degrees. We really try not to play around with negative angles, because you can, or angles that are greater than 180 degrees, because we can just represent them differently, right? Like you might say that a 180 degree angle looks something like this. Or maybe we say an angle, just say an angle that looks something like this, right? We could have two possible measures. We could have our measure right here, or we could have our measure on the other side, right? It could be either of those. So generally, we're going to stick with this right here, this smaller than 180 degrees. Okay. Yeah, I guess before I go, maybe I should draw some examples of these. Why not? I got ahead of myself a little bit, maybe. An acute angle would look like this, right? Nice and cute. A right angle would look something like this, right? Exactly right. And we usually draw like a little square here to show that that's a right angle. An obtuse angle would look something like this. Out. That's obtuse. That would be so that this is our acute angle. Here's our obtuse angle. And a straight angle, of course, is just a line, right? Straight angle is a nice fancy way of saying a line. Okay, that's this whole part right here. Straight angle. Okay, so that's angles. Yeah, stay tuned for part 3 where we'll talk about links.